So students, today in our thermodynamic class, we will learn the concept on enthalpy and relationship between delta H and delta U. Let's start. Good morning students. In our online chemistry class today, we are going to learn the concept on enthalpy from thermodynamics. Okay. Now, let's see. Actually, heat change of at constant volume permits us to calculate the delta U, that is our internal energy. Okay, so under this condition, rather seizable volume changes can occur in work done is equal to the P delta V. Now, to avoid this necessity, considering the PV work when heats of reaction are measured at constant pressure, so we define the new thermodynamic property called heat contained or enthalpy. Okay, so we should actually write enthalpy as H, and enthalpy is defined as the total heat content of the system at constant pressure. So enthalpy should be defined as the total heat content, H equals to U plus PV, and here is mathematical description. So thus enthalpy may also be defined as the sum of the internal energy and pressure volume energy of a system. Now here in this case we can write actually the delta H value, the magnitude of enthalpy depends on the initial and final states. So delta H would be written as the H final minus H initial. Okay, now here enthalpy is also an extensive property. This is an extensive enthalpy, and you can write it here extensive property. Okay, so since it's extensive property, and let a chemical system has internal energy U1, volume V1, okay, and let it react with constant temperature and constant pressure to give another chemical system, internal energy U2 and volume V2. So you can write from here, if H1 equals to U1 plus PV1 and H2 equals to U2 plus PV2. Okay, so now and H1 be the enthalpy of the first system, this is H1 be the enthalpy of the first system, and H2 be the enthalpy of the second system. So from here, if we calculate delta H, it should be equals to delta H H2 minus H1. So putting this value over here, we get U2 plus PV2 minus U1 minus PV1. So U2 minus U1 plus become V2 minus V1. So we can write it delta U plus P delta V. So this is our actual delta H value. Now from here we can actually state that since delta U is equals to Q plus W, delta U is equals to Q plus W, from first law we know, from first law of thermodynamics, delta U is equals to Q plus W is heat energy and is work done. And suppose only expansion is involved in this change, so expansion work done, so we can write W equals to minus P delta V. So by calculating these values from here, you can say that it is Q plus W, and this is minus W from here. Okay, is minus W, so delta H should be equals to only Q. Okay, and this is at constant pressure. So at constant pressure we can prove that this is the actual delta V value from here. If we calculate it from first law at constant pressure, that delta H is equals to actually V. It summarizes that the system delta H shows the QP. Now we are going to a relationship between delta H and delta U. Actually, the relation between delta H and delta U. Okay, relationship between delta H and delta. So we already know from gas laws that PV equals to nRT. Okay, at this point you all know. And in case of for any reactant portion, so you can write PVR for any system, NR RT for reactants. Okay, and for the products we can write PVP, this P for product and this R for reactants, goes to NP RT. Okay, now actually by subtracting these equations we get P Vp minus Vr Np minus Nr RT. This gives us P delta V equal to delta N RT. Okay, so from here you can write actually this is the delta N. So you can write it delta G also. So this is actually formula that is given by, and from here actually the energy change at constant pressure, constant pressure is equal to the energy change at constant volume plus energy change the number of moles of gaseous products and reactants into RT. Okay, so this we can summarize from here, as since we have already calculated that so P delta V value from here, so we can write P delta V equal to del H minus del U. From here if we come, so delta H minus delta U equals to delta Ng RT. So delta H equals to delta U plus delta Ng RT. So this is the basic relationship between the delta H and delta U in the system. So the conditions from here, so you can write it down. And since delta H equals to QP, delta H equals to QP, so from here you also can write that since delta H equal to QP and delta U is equals to or QV, we all know, and we prove it in another different system. Okay, so up to this point it will be enough for you for this purpose of the concept of enthalpy. Okay, hope you like this video, students, and if you want any more video on thermodynamics, you can ask me. Okay, so please subscribe my channel to get more information on online chemistry class. Okay, bye. So students, hope you have understood the video, and this is the summarized condition of the relationship between delta H and delta U, and this is the delta H equal to QP at constant pressure. It is equals to the heat energy, and this part shows the delta H equal to delta U plus delta N GRT. Okay, goodbye students, hope you are all well. Thank you.